let's look at example 4.5.3. Felicity attends Modesto Junior College in Modesto, California. The probability that Felicity enrolls in a math class is 0.2, and the probability she enrolls in a speech class is 0.65. The probability she enrolls in a math class, given that she enrolls in speech class, is 0.25. So we'll refer to M is math class, S is speech class, and M given S is math given speech. Part A, what is the probability Felicity enrolls in math and speech? Well, we have a formula. Probability of math given speech is equal to the probability of math and speech divided by the probability of speech. Since we're looking for probability of math and speech, let's do a little bit of algebra and rearrange this formula. We're going to multiply both sides by probability of speech so that we end up with probability of math given speech times the probability of speech, which is the hint that they give us in the problem, but that is where they're getting the hint from. They're using our given probability formula rearranged so that we can calculate it a little easier. So, math given speech is 0.25. Speech is 0.65. And if we multiply those together, we end up with 0.1625. Part B, what is the probability Felicity enrolls in math or speech? This is coming from our addition rule. Probability of math or speech is equal to probability of math plus probability of speech minus probability of math and speech. We're subtracting out math and speech because when we count for the probability of math and we count for the probability of speech, we actually double count the situations where math and speech are at the same time. Since we're double counting, we want to subtract one of those double counts out to make sure that our counting is accurate. So that's why we have this subtraction at the end happening. And we can look above. Enrolling in a math class is 0.2. Enrolling in a speech class is 0.65. And then we're going to subtract out the overlap that we got. We're going to subtract out the intersection from the previous problem above. And that gives us 0.6875 for our probability of math or speech. Part C, are M and S independent? So probability of math given speech is 0.25, but the probability of math is 0.2. These are not equal. So math and speech are not independent. We can also see this in just the definition of math given speech. If she enrolls in a math class, her probability is 0.2. But the probability she enrolls in math, given that she enrolls in a speech class, is different. It's 0.25. Meaning that if she takes a speech class, it changes her probability of enrolling in a math class. So that's how we get this not independent scenario. Not only are the numbers not lining up in the formula, probability of math given speech is not equal to the probability of math, but also the probability she enrolls in a math class changes once we throw this idea that she's enrolled in a speech class. Part D, are math and speech mutually exclusive? Meaning, is the probability of math and speech 0? Well, we found that out in Part A. Part A up here calculates math and speech, and we get 0.1625. That is definitely not 0. So math and speech are not mutually exclusive.